Hello students, today I am going to explain you from question number 7. As in the previous session you have seen, we have completed till question number 6. In the exercise 8.2 we are seeing the questions of general term, or you can say that we are finding a particular term in the expansion of a plus b whole power n. Now in continuation with that, let us see the question number 7. In question number 7 we have given that one expansion 3 minus x cube upon 6 whole power 7. Okay, now in this expansion some terms are coming. As you can see, the power is 7, so total number of terms will be here 8, one more than the given index. Okay, so they are saying that find out the middle term in the expansion given over here. For example, suppose if I write down the 8 terms over here, then see, this is first. Suppose if I say similarly second, third, fourth, fifth, 6, 7 and 8. Okay, suppose if I take these 8 terms and we have to find out who will be the middle term over here. In the book also and in the reference book also, there are many formulas are given which you can find out easily. With the help of that you can apply the formula and you can get the value of middle term. But with the help of logic also we can easily find out who will be the middle term in these 8 terms over there. Normally here index will be given around 10 to 15, so you can find out manually also. There is no formula required. For example, suppose if I cancel from here one term from the one end, then here also I will cancel one term. Similarly again I cancel one term, here also I cancel the one term. Again I cancel one term, and here also again I cancel one term. Now you observe three terms I have cancelled. Okay, from the left as well as from the right. Now if I cancel one term from here, then I need to cancel one term from the right side also, and in that case no other term will remain. So we can say that here the middle term will be fourth term and the fifth term, that we can see. Directly we can find out. So remembering the formula is always a problem in over there, because we forget the formula and we cannot apply it. Okay, so here if you remember this method you can easily find out. You have to cancel the same number of terms from the left and from the right, and whichever terms remain after cancellation which could not be cancelled further, that will be the middle term. Because you see 8 terms are there, then exactly who will be the middle term we cannot claim over here. It can be fourth or it can be fifth. Suppose if I say 7 terms are only there, then the middle term will be in that case it will be fourth term. Okay, so we can say that here in the case of even number of terms there will be two middle terms, and in the case of odd number of terms there will be only one middle term. Okay, so let us see. Now we will find out the value of fourth and fifth term over here. First we shall write down here the value of a is equal to 3, b is equal to minus x cube upon 6, and the value of n is equal to 7. Now we shall apply the formula of TR plus 1. So TR plus 1 formula is NCR, that is written in front of you also, into a to the power n minus r into b to the power of r. Okay, now let us apply the formula. So first value of n I am putting here 7 CR into a, value of a is here 3 whole power 7 minus r. Okay, into b, that will be minus of x cube upon 6 whole power r. Now this will be, we can say, value of TR plus 1. We can simplify further also, but it is better we shall put up the value of r and we can find out further requirements. Okay, now first we shall describe who will be the middle term here. So we'll say that since the value of n is equal to 7, therefore total number of terms in the expansion in the expansion r, that will be 8. Therefore, we can say that middle terms are middle terms are 4, comma 5. Okay, so these are my middle terms. Now if I want to find out the fourth term, okay, so you know that if I want to find out fourth term, in that case the value of r will be equal to 3, and if I want to find out the fifth term, then value of r will be equal to 4. Okay, because one lesser we shall keep in the formula tr plus 1. So now we'll write down, we put r is equal to 3 in equation 1. Equation 1 I have not given that one, so that we can give it here as equation number 1. Sorry. So let us put up the value here. This will be t3 plus 1 is equal to 7 c3 into 3 to the power 7 minus 3 into minus x cube upon 6 whole power. This will be 3. Okay, because value of r we are keeping over there 3. Now let us simplify further. So this will become as t4 will be equal to 7c3. If I simplify, 7 I will open till 3 places, and upon I will keep it here factorial 3. That will be 3 into 2 into 3 to the power 7 minus 3, that will be 4 into, now see, minus sign coming under the odd power, so minus sign will remain, that I am putting over here, and power of x will become here 9 upon cube of 6 will come. Okay, now here we can cancel something, 3 and 2 and 6 can be cancelled, so remaining will be here minus of 35 into 81 into x to the power 9 upon 216. Now some of the terms again we can cancel between 81 and 216. Some cancellation will be possible. For example, if we cancel by 9, so 9 9s are 81, 9 2s are 18, carry 3, 36, 9 4s are 36. Now by 3, 3 8s are 24 and 3 3s are 9. So I think the value of T4 will come here as minus 105. 35 into 3 will become 105 upon 8 into x to the power 9. This will be your first answer. Okay. Now we shall put the value of r is equal to 4 in equation 1. So now we shall write down, we put r is equal to 4 in equation 1. So in that case, t4 plus 1 will be equal to, now see, I am putting over there. So what is the first term? First term is I think 7cr, then 3 to the power of 7 minus r. Let us see, 7cr, 3 to the power of 7 minus r. So first we shall write down that one. This will become 7c4 into 3 to the power of 7 minus 4 into minus x cube upon 6 whole power, that is r. That will become here, because value of r is equal to 4 now. Now see, 7c4 and 7c3 will be same only, because if we apply the complement rule, 7c4 we can write down as 7c7 minus 4. Okay, so this can be equal to 7c3 into 3 to the power 3 into, now see, the minus sign is coming under the even power, so minus sign will eliminate. Power of x will become here 12 and upon it will come 6 to the power 4. Okay, let us simplify further. 7c3 value we can find out now. So this will be 7 into 6 into 5 upon 3 into 2. 3 cube is 27 into x to the power 12 upon 6 to the power 4. I wrote 36 into 36. Otherwise, we can write down 1296 also. Okay. And here, if you require description, you can write down 7C4 can be written as 7C 7 minus 4, and hence it can be written as 7C3. Okay. So this is the reason for the 7C4 we are writing as 7C. Now further, here again we can have some cancellation. 3 and 2 6, and 6 can be cancelled. Then 9 3s are 27 and 9 4s are 36. Now I think it is not possible to cancel. 7 into 5 35, into 3 that will be 105 upon 36 into 4 that will be 144, and into x to the power 12. This will be, I think, value of T5. If any calculation mistake, if you find, please make it correct. Otherwise, I think this will be the second middle term of the given question or the given expansion. Now, let us see one more question of the similar kind. So, you will be able to handle the question in the similar manner. Now, question number 8 we shall see here. Find the middle term in the expansion of x upon 3 plus 9y whole power 10. First of all, see here. Again, if I write down in the same manner 10 terms, sorry, here power is given 10, so total number of terms will be 11. So if I show you in the same manner 11 terms, let me write down all the terms first of all. Okay, now suppose if these 11 terms, if we do the cancellation, yes, okay, now it will be visible clearly to you. Now if I do the cancellation, see, observe, if I cancel one term here, then I am going to cancel one term from the right side also. Again, one from the left, one from the right. Same way, if I proceed, one from the left, one from the right. Again, one from the left, one from the right. And again, one more term from the left and right. Observe, from the left, how many terms I have cancelled? 5. And same way, from the right also, I have cancelled the 5 terms. Then who is remaining in the middle? That is term number 6. So we can say that sixth term will be the middle term in the expansion given over here. You need to remember only one thing: when the number of terms will be odd, the middle term is only 1, and when the number of terms are even, then the middle term will be 2. It doesn't depend on power, because power doesn't indicate the total number of terms. The total number of terms will be always one more than the power given in the question, power or index, you can see. Okay, so here we can say that the term number 6 will be the required middle term. Now first we shall write down the value of a will be equal to x upon 3, b will be equal to 9y, and n will be equal to 10. Okay, now let us start. First write down the value of t r plus 1. So we'll write down the value of t r plus 1 is equal to, that will be 10 CR into a to the power of n minus r. So it will be x upon 3 whole power n minus r into b to the power of r. So 9y whole power of r. Okay. Right now I am not simplifying this one. I am just keeping as equation number 1, because I am not finding a scope of simplification over there. However, 3 to the power of 10 minus r and 9 to the power of r, that we can have some simplification, but leave it. We can put up the value of r and we can have the final simplification. So now we'll explain. Since the value of n will be equal to here 10, therefore total number of terms, total number of terms in the given expansion. The given expansion would be 11. Okay, because one more than that, so we can say therefore middle term is sixth term. Okay, now let us find out the value of sixth term. So therefore we shall put value of r is equal to 5 in equation 1. Okay, so let us put up the value of r is equal to 5 in the first equation. So this will be t 5 plus 1 is equal to 10 c5 into x upon 3 whole power 10 minus 5 into 9y to the power 5, right? So we can say that here value of r we have kept. Now let us simplify. 10c5 we do not have any option, because if we apply the complement rule then also it will remain same only. So let us open 10, we will open till 5 terms. 10 into 9 into 8 into 7 into 6, and in the denominator it will come factorial 5. So 5 into 4 into 3 into 2 into the value power of x is here 5, upon it will come 3 to the power 5 into 9 to the power 5, and same way multiply y to the power, it will be also 5. Okay, 5 and 2 will become 10, and 10 will be cancelled. Again 4 ones are 4 and 4 twos are 8. 3 ones are 3 and 3 threes are 9. Okay, so here it will remaining 3 into 2 6. This is 6 here, and 6 will become 36 into 7 into x and y, that I am writing whole power 5. Their power I am going to combine into 9 to the power 5 upon 3 to the power 5, that I can combine here, that will be 9 upon 3 whole power 5, because both the powers are same. So this will be 3 ones are 3 and 3 threes are 9. So remaining is here 36 into 7, 36 into 7 into, see it is remaining 3 to the power 5, that will become 240 into xy whole power 5. So that will be the value of t6. Only we need to multiply it all. So we will not waste our time for this multiplication, that I will give you afterwards. Okay, or you can also do it by your own. So this way, for the odd number of terms and for the even number of terms, we can easily find out their middle terms. Now let us see the next question. We are going to see now question number 9. In the question number 9, see what they are saying. In the expansion of 1 plus a whole power m plus n, prove that the coefficient of a to the power m and a to the power n are equal. Okay, means we have to find out the coefficient of term a to the power m as well as a to the power n, and we have to show both are coming same, equal. Okay, so first of all we shall find out the general term in the expansion of 1 plus a whole power m plus n. So first we shall write down here, we'll say in the expansion of in the expansion of 1 plus a whole power m plus n, we can say that a will be equal to 1, b will be equal to a, and n will be equal to m plus n. Okay, So we shall put up the value of t r plus 1. So therefore t r plus 1 is equal to n c r. So value of n what we have? M plus n c r into a to the power of n minus r. So 1 to the power m plus n minus r into b to the power of r means a to the power of r. Now see, m, n and r, these all are positive integers. Okay, if it is negative then also we do not have any problem if we are keeping as a power of 1. And 1 to the power any number, always answer will be 1 itself. So the middle term written in the tr plus 1, that we can leave it. So this will be tr plus 1 is equal to m plus n cr into a to the power of r. Equation number 1. Now further, we'll find out for coefficient of a to the power m. We compare. See, in the beginning of some question, to find out the coefficient, we are going to compare the similar terms. Since we need to find out the coefficient of a to the power m, so here similar kind of term is coming, a to the power of r in the equation number 1. Okay, a to the power m and a to the power r, both are similar terms. So from here what I can say, the value of r will be equal to m, because if the bases are same, power will be also same. So that value I can put up in equation number 1. So we can say that therefore by equation 1, t m plus 1, value of r I am keeping here m plus n cm into a to the power m. Now see, who will be the coefficient of a to the power m here? Tm plus 1 value we found, which is coming in your right hand side. Okay, so if I leave a to the power m, whatever is remaining along with that term is called as the coefficient. So we can say that therefore coefficient of a to the power m is equal to m plus n c m. Okay, now here one more thing is remaining, that we need to find out the coefficient of a to the power n also. Okay, so this one we can give it as equation number 2. Now we shall find out the coefficient of a to the power n. So we shall write down in the similar way, for coefficient of a to the power n, we compare a to the power n is equal to a to the power r. So therefore r will be equal to n. Okay, put up the value again in the equation number 1. So we can say that therefore by equation number 1, if I put up the value, this will be t n plus 1 is equal to m plus n cn into a to the power n. You can check the equation number 1. I am just keeping the value of r as n. Okay, look at the equation number 1. In place of r, I am keeping the value n over there. Now here if I try to find out the coefficient of a to the power n, so I will write down therefore coefficient of a to the power n is equal to m plus n c n. Now see, coefficient of a to the power n also came, and look at the second equation. Sorry, look at the second equation. So in that you can see the coefficient of a to the power m. Now one thing is very clear, both are right now they are not same. But here one simple rule will apply, that is called as the complement rule. Complement rule I have applied several times. You know it. NCR is always equal to NC n minus R. Okay, these two terms are always equal. So if I apply this rule, it will become m plus n will remain same only the term coming in the suffix that will be changed, m plus n minus n minus r. What is n here? M plus n, and r will be equal to n. Now you can observe n and n will be cancelled and it will be remain, write down properly, coefficient of a to the power n is equal to m plus n c m, and this is your equation number third. Now check equation number second and equation number third. You can clearly say that both the coefficient are coming same. So we can write down at last from equation second and third we observe coefficient of a to the power m and a to the power n are same, or you can write down equal. Hence, that is only it was required to be proved in the question. Okay, now let us see today's last question. I am leaving some question in between. 9th question I have taken, but 10th and 11th I am not taking. The reason behind that, 10th and 11th we shall start from the fresh session. Okay, because these two questions are little lengthy, especially question number 10. So these two questions could not be taken right now. We can take one small question, that is question number 12. This is your last question of the exercise 8.2. So see the question. Find the positive value of m for which the coefficient of x square in the expansion 1 plus x whole power m is 6. See what we have given that. First of all, we shall talk about the given expansion. So we have given that given expansion is 1 plus x whole power m. Now what they are saying here, in this expansion, if we try to find out the coefficient of x square, that is coming here 6. So in that case, find out the value of m. Okay, so first of all, in the given expansion, we shall find out the coefficient of x square by our own method. And since that coefficient is given here 6, so both we can compare and then we will try to find out the unknown value m. Let us see how it is possible. First, I am finding the coefficient of x square by our method. So here, first you can see value of a. I can say it is 1, b will be equal to x, and n will be equal to here m. So therefore, the value of tr plus 1. Formula is NCR, so it will be MCR into a to the power of n minus r. So that will be 1 to the power of m minus r into b to the power of r. So x to the power of r. So we can write down this one further. tr plus 1 is equal to MCR into x to the power r, because 1 to the power of any number will be equal to 1 only. Now, which coefficient we required? We'll write down for coefficient of x square. We compare, as we have compared last time to find out the coefficient of a to the power of m, a to the power of n, similar kind of terms. So here, to find out the coefficient of x square, we can compare a similar term in the equation number 1. That similar term is coming here, x to the power r. So we can say that r will be equal to coming here 2. Okay, now put up the value of r is equal to 2 in equation 1. So here we can say that therefore by equation 1, t 2 plus 1 is equal to mc2 into x to the power 2. Now we can say that along with the x square, whomsoever is coming, that is called as, it is coefficient of that. So here we can say that therefore coefficient of x square will be equal to MC2. Okay, now further, according to the question, what is the coefficient of x square is given? That is given as 6. So we can write down according to the question, coefficient of x square is given here as 6. So now if I put up the value MC2 what we got here, so we can say that therefore MC2 is equal to 6. Okay, now if I compare both of them, how we can get the value of M over here? So MC2 we need to open over here, there is no choice, we need to open the MC2. So if MC2 if I open, this will be factorial M upon factorial 2 into factorial M minus 2. If I apply the formula of NCR, traditional formula, you know it. Okay, now further if I go, factorial M, you see I will open till M minus of 2. So this will be M, if I comes outside, then in the factorial remain M minus 1. M minus 1 also I have taken outside. Then remaining will be here M minus 2 in the factorial. So M minus 2 will remain in the factorial. Upon it will be value of factorial 2 will be equal to 2 and into M minus 2 factorial is equal to 6. Okay, now M minus 2 factorial and M minus 2 factorial we can cancel. This will remain M square minus M and 2 I have transferred there, multiplied with 6. So we got here quadratic equation M square minus M minus 12 is equal to 0. Now let us simplify this equation. So multiplication required 12, we can write down M square minus of M plus 3M minus 12 is equal to 0, right? So here M we can take common, remaining is here M minus 4 plus 3 we can take common, remaining is here again M minus 4 is equal to 0. So here we can say that minus 4 is coming common, remaining is here M plus 3 is equal to 0. Now these two brackets I compare with 0 because multiplication is coming 0 both of them. So 1 must be 0. So M minus 4 will be equal to 0 or M plus 3 is equal to 0. So value of M I am getting here plus 4 and minus of 3. Now see, value of M cannot be equal to minus of 3 because it is coming in the case of combination. And I think in the question also maybe M is given as a positive number. Let us see. Find the positive value of M. See, in the question only mentioned. Okay, so we can say that since M cannot be equal to minus of 3, since M is more than 0, it is given in the question. So we can say that finally the value of M is here 4. This is our required answer. Okay, and this completes the question number 12. Now in 8.2 remain only 2 questions that we will finish in the next session. Okay, thank you.